Hello students, in this video we'll see how to use the continuous joint distribution function of two random variables to compute a certain probability. Let's consider two random variables. X and Y with a joint PDF f of xy is a constant k, x times y squared, in the region x between 0 and 1, and y will be between 2x and 2. So the first thing we do when we have a joint PDF problem is we sketch the support of the joint PDF. So if this is the x-axis and this is the y-axis, we know that y starts at the line 2x. So there's my line y equals 2x. And when I plug in x equals 1, that will correspond to a value y equals 2. So if y is between 2x, this line 2x and 2, it looks like we are in this triangle right over here. So this is the triangle in which our PDF resides. So the first thing we need to do is we need to find k. So to find k, so first find k. And I will integrate over this region and find the value. So x will go between 0 and 1 in this region. Y will go between 2x and 2. And then I will have a k times xy squared dy dx. We can pull this k out of the integral. This is going to be k, the integral from 0 to 1. And then I will do this antiderivative. So I'll have an x and then a y cubed over 3 from 2x up to 2, and then I'll have a dx. So continuing over here, we'll have a k, the integral from 0 to 1. And then when I plug in 2 to this, I'm going to have an 8/3 x, so I'll have an 8/3 x. When I plug in 2x over here, I'm going to have an 8x cubed over 3. So I'll have 8x cubed over 3 times x. That'll be minus 8 over 3, x to the 4th power, dx. We can pull this 8/3 out, so I will have 8k over 3. And then we will have an antiderivative of x will be x squared over 2 minus x to the 5th over 5, evaluated from 0 to 1. So this will be 8k over 3. And then I'll have a 1/2 minus a 5th. So 1/2 minus a 5th will be 5 minus 2 over 10. So it'll be 3 over 10. The 3's will cancel out. And this will be equal to 4/5 of k. So k must be equal to, so 4/5 of k must be equal to 1. So this is equal to 1, since it's a PDF. Therefore, this tells me that the value k in this problem has to be 5/4. Now that we have the value of k, we can solve a problem. Let's find, for example, the probability that x is less than or equal to 1/2. So we look at the portion of our region which this probability is true. So we'll plot our region again. Here's the x-axis, here's the y-axis. Here's y equals 2x. And when x is equal to 1/2, that corresponds to the value y equals 1. So we are in this region right over here. And that corresponds to that part, and we also have this portion over here. So that's the region we will integrate over. So this probability will be equal to, x goes between 0, so let's look at this region. So x goes between 0 and 1/2. Y will go between this line 2x and 2. And then I will integrate my PDF. My PDF is k times this quantity, so that'd be 5 over 4 times xy squared dy dx. So that 5/4 will come out. Then I'll have the integral from 0 to 1/2. And then I'll have an x and then a y cubed over 3 from 2x up to 2 dx. And so this will be 5/4. And then we will have the integral from 0 to 1/2 of, I'll have 8/3 of x. And again, I'll have minus 8/3 x to the 4th power dx. I can pull that 8/3 out, so of course 8 over 4 is going to be a 2, so I will have a 2 times 5, so I'll have 10/3. The integral from 0 to 1/2 of x minus x to the 4th dx. So this is 10/3. And then we will have x to the 1/2 power, x squared over 2, minus x to the 5th over 5, from 1/2 to 0. So this will be 10/3. When I plug 1/2 into this, I'm going to get an 1/8. When I plug 1/2 over here, I'm going to get a 32. 32 times 7 is 1 over 160. And so after simplifying this fraction, we see that this value is the probability that x is less than or equal to 1/2. Thank you very much.